Assalamu alaikum, my name is Shahriar, and in this video we will see some commonly used digital signals and some operations of digital signals. Basically, the different signals we use in our daily life, like speech, biomedical, and communication signals, and audio video signals, they're analog in actually, but to process these signals we need to convert in digital form by using ADC converter, analog to digital converter. And how digital signals basically notate. So basically the notation of digital signals is like this. So here we see in this it is the second sample with amplitude x of 1. Now we see some of the common digital sequence. The first one is unit impulse function. The unit impulse function is basically this function where it has value only at n equal to 0, otherwise it will be 0. Okay, and the next one is unit step function. It has value 1 when n is positive or equal to 0, like from 0 to positive infinity its value is 1. So now we see the shifted variant of unit step function. Suppose as it is u of n, so if we want to write u of n plus 2, so we move two samples in the left side like this one. So what is the exponential function? It is basically a exponential function which is a decaying negative of exponential function. Now we see what is a system. Basically suppose we have x of n is the input, and when some algorithms applied or some theorems applied on it, then we get y of n. Then this complete make a system. Now move on. What is linearity? Basically it is a linear function that holds the superposition theorem. In superposition theorem basically you have two things. First is homogeneity and the second one is additive property. So what is homogeneity? Suppose we have a signal x of n with output y of n. So when we multiply some scalar like alpha in input, then we get the same scalar at output side. So it is called homogeneity. Now what is additivity? Suppose we have two signals like x1n and x2n, and with output y1n and y of 2n respectively. So when we combine these two signals and pass through a system, and then we get the combination of these two output, then it is a additivity. So now we see some examples of additivity and homogeneity. Suppose we have a function y1 y of n equal to 10 into x of n. So if the input is multiplied by 10 to generate output, and also we have x1n is u of n and x of 2n is delta n, so then output must be y1n 10 of un and y2n must be 10 of delta n respectively. If it holds this two equations, then it is a homogeneity, otherwise it will be non-linear equation or function. Now what is time invariance or time variant? With the passage of time, if our function remains the same, then we will say this is time invariance, but if our function change, then we will say it is a time variant function. To check time invariance or variant, we basically find this rule. We basically follow two steps. The first one is delay and the second one is replace. In delay, we basically put some time which is apply only on the function, and in replace we basically replace all the t or n by t minus k or t minus n. So we see some examples for better understanding. Suppose this is our function x of 1n. So when it moves with minus n naught time, then we see it is the same as it was before. So we will say it is a time invariance function. And the similar case is here y1 of n, and with n naught time it is remains the same. So we will say it is also a time invariance function. Now move on some further examples. Here we have a function 2x into n minus 5. So first of all we find delay. I already told you that delay means that only applies on the function. So here we apply y1 of n into minus n. So when we apply minus n naught, so we form this equation 2x1 of n minus n naught minus 5. So when he replace, then we actually also put n, replace n by n minus n naught like this one. So we see these two equations are same, so it is time invariant because there is no change. So move on the other example like this one, y of n equal to 2x of 3n. So when we apply delay, then we get y1 of n equal to 2x 3n minus n naught, because here only we apply delay in function, but in replace we actually replace n by n minus n naught like this one. So we see this equation 1 and this equation 2 is not same, so we'll say this is a time variant function. So move on to the next topic, which is causal. So the system that depends only on current and past value input, then it is a causal system, but if it depends on future as well, then it will a non-causal. For example, suppose y of n equal to 0.5 x of n plus 2.5 x of n minus 2 for all n greater than or equal to 0. So when we put n equal to 0, then we get 0.5 x of 0 plus 2.5 x of minus 2, as here 0 is the present value like which we applied, and minus 2 is the past value because it is negative. So it is a causal function. So we'll see some other example like this one. This is our function y of n equal to 0.25 multiply n minus x of n minus 1 and 0.25 and x of n plus 1 and minus 0.4 x of y minus 1 for all n greater than or equal to 0. So again, when we put n equal to 0 in our function, then we get 0.25 x of minus 1 plus 0.5 x of 1 and minus 5 x of minus 1. So here we see this is the positive value, which means it represents a future value. So we say this is a non-causal. So this is the last topic for today. Allah Hafiz.